she was like, oh, fine. What the hell, did I change it? Let's go left to right. As long as we change it, I doubt that's.
Yeah, I just fixed my
Right? I think she forgot we said something that. I can't do it.
Did you get your test scores back, John? For math?
Because
Because I was told I'm gonna get mine today. So I'm gonna see what happens.
It's only half of one, right? We'll reload it, see if it stays.
I actually had a teacher do that in one of the previous
I
classes.
think she has it set to where, no, they went back, okay, it's not figured. Let's see though, unless you just do that.
Morning.
Morning.
You guys are so sad that class got canceled on Wednesday.
I was. I don't know about anyone else, but I was.
I was up at 6:30 in the morning, ready to go.
All ready to go, right?
And my buddy's like, did you get that text message? No. And that text message came at like 10 o'clock for me.
Right.
Like, thank God I didn't drive out there.
Yeah.
Things weren't waiting at the bus stop.
That would have been annoying, right? Why am I not getting picked up to the bus? Did I miss the bus? So I moved there, hopefully it's on campus, I moved everything back. So this week we'll do today's lecture and one more lecture. So the midterm that was supposed to be Wednesday is now Monday. So everything just got shifted, which hopefully will work out at the end of the semester. I think I had one extra day in there, so you lost a lab day, which is probably fine. Do you have any questions? Midterm, right, will be next Monday. I kind of told you it's a combination of, there'll be a code portion, but also, it says written, but really it'll be on Canvas, some kind of multiple choicey type thing. You can have a 3x5 note card, we talked about that, handwritten, so I didn't bold it and underline it, but hopefully you saw on the slide here, right, handwritten. In front and back's fine too as well.
So once somebody else handwrites it.
Yeah, I don't care whose handwriting it is. If I use someone else's handwriting, it would be a lot better than what I could write on my card. But really, I use it as a study tool, so it's better for you to do it yourself. Otherwise, you'll spend all class trying to figure out how the person wrote all the notes. If you do it with the person, then figure it out.
Is there a study guide or anything?
Not really. I put one up there, but it literally just says like, here's everything we've gone over. So, that's what it's on, right? So from the first lecture to now. I will tell you that the code portion is going to be class-based. So today's lecture and the next lecture are key to writing the code portion. I'm not looking for heavy logic on the code portion because you don't have time, right? You're only going to have like an hour plus to write all the code. So I'm looking, do you understand the structure of a class and can you have it interact with some functions?
Is code just classes or classes and structures?
It'll just be classes, right? So it'll have some kind of data associated with it and then some member functions to work with it. But the logic inside of those functions will be pretty easy.
Okay.
So if you can structurally write it up, maybe something you want to write on your 3x5 note card, kind of what you take from today's lecture and maybe the next lecture, that might be helpful. Because while you'll get feedback from the compiler, the only feedback from the compiler you're going to get is you failed, right? Something's not right. So you can figure out what line number it's on, but I'm not going to be able to help you figure out what the actual form is. So having that written on it on a note card could be helpful to look at it. Just make sure you write it correctly on your note card. Right, that can be important. Questions there? So this class, next class, we're going to talk about classes, and classes, like structures, hold data, but then the thing that classes allow us to do, once again, is to add behavior. So we're going to add functions to our objects to kind of, right, act on the data that's inside of them. So last class, we presented this idea of a day of year, right? And so anytime that you work on class-based stuff, and object-oriented type stuff, right, we have to view things as objects. So we have to look at, say, what is this and how can I represent it? And the two big ways we represent it are via attributes and behaviors. right? And attributes are the data of an object. So attributes are, what is it made up of, right? What are the data that we can store in this? And then behaviors are like, what can it do, okay? For now, because our class objects aren't too crazy, most of the behaviors are things that act on our attributes. So when we think of a day of the year, what kind of attributes do we have? What's a day of the year made up of?
Yeah.
Okay, so it's made up of a day. I'm good with that. And what else?
Month.
A month. It could be a year, but I'm doing very generic. It's a day of year, so we're not gonna. We won't keep the year. Mostly because I don't want to type that. Right? It could be that. So these are kind of right. These are attributes. These are data points. And in C++, like most languages that have types, right, we have to associate a type with those. All right. And so when we think of a day, we think of a what?
Int.
Int. Right. Because right, there's no like 6.5. Right. It's January 6.5. Right. And then month also would be a what? And then, does that make sense? All right. What we're going to get to today is the idea that, right, this object should always represent a day of a year, and so those days and those months should be correct ints. Okay, ints can go from what to what? I don't know.
0 to like 5,000 something.
It's big, right? It's actually negative 2 billion to positive 2 billion.
Jeez.
Okay.
It's day 1.9 billion.
Right? And you don't need to memorize that. You just need to know that ints are large. They can hold a lot of numbers, right? But really, days should only be from what to what?
1 to 31.
1 to 31, and a month should be from
1 to 12.
1 to 12. Okay.
Technically, the day would need more like parameters because like it would be like on February it'd be like only 28.
Depending on the month, right? The day might change. That's true. And notice we said 1 to 12 and 1 to 31. We choose that, right? It could have been 0 to 30. Could have been 0 to 11, right? If I decided to include ones, right? We chose to make them ints. You could have made them, right? You could have made the months characters. Although there's multiple ones that have the same characters. You have to deal with that, right? Once again, we kind of get to choose internally, right, what our data is going to look like, right? Externally, we're going to tell the user this is what, right, when you do certain things, this is what it's going to look like. But internally, we have the choice of kind of deciding what data type I want to use, what range of stuff I want to use. Does that make sense a little bit? Questions so far? Right, and then we'll get into behaviors a little bit, but I kind of want to set up our class. So today will actually be a lot of me typing and a lot less of me going through slides, which maybe you'll like that. Classes, like structures, get created above main, right? And the only thing is structures start with the keyword struct, and classes start with the keyword class. By style convention, we do them uppercase and like an uppercase camel case. So, right, all of our variables have underscores in them, right? Class names are all uppercase separated by, right, words separated by uppercase letters. Does that make sense? And then the thing that we always try not to forget is that lovely semicolon at the end of my class. All right. We're going to talk about encapsulation here in a minute and the keyword public. For now, I'm just going to put it in there. Right? That gets by convention spaced over 1. Right? And then let's talk about our member names. So we're going to have a month and I'm going to have a day. By convention, you'll also see that I put underscores at the end of all of my data points in my class. Okay? So day is day underscore, month is month underscore. I do that to remind us that that's the data of the class object. Okay? Because very soon we're going to get into things like functions with parameters, right? And so we're going to remind ourselves what is data of the object and what is external data, right? Or localized data that we want to do. Does that make sense so far? Right? What does it look like right now? It doesn't really look like a class. What does it look like? A structure, right? Because it's just a blueprint for just data. Okay. What classes allow us to do is to add behaviors in as well. So I'm going to add one behavior into my class, and that's going to be a function called output. Right? It's a void function, right? We've already talked about functions Today, though, when we talk about functions, we're going to talk about functions that belong as part of a class, right? So it's going to relate somehow, right, to a day of the year and possibly relate to month and day. Does that make sense a little bit? Questions so far? Anyone want to guess what the output function is going to do?
Output.
It's going to output something, right? So just like with regular functions, we're going to copy it and paste it below main, right? And once again, I'm going to change my semicolon to curly braces. All right, so that's just like we did before with regular functions. The difference now is that that output function also belongs to my class, right? Output is part of the class day of year. Up here, that was easy to see because we said class day of year, open curly, so everything inside of that's going to be part of my day of year class. Down here, though, this function doesn't say it's part of it unless we say day of year, colon, colon. Right? So class name, 2 colons, which is called the scope resolution operator, and then the name of my function. So you notice from top to bottom, what did we do? We changed the semicolon to curlies. We added the class name, colon, colon before the function. Okay? I didn't add anything to the parentheses. If there wasn't anything above, there's nothing below. It was void above, so it's what? Void below. Right? Nothing's going to change there. Right? And then in here, I get to decide, right, what is the behavior of output, right? I get to decide for my class, when someone calls the function output, what is going to happen, right? For me, right, I want to make sure that it outputs my class object's data, right? So I'm going to say today is, and then I'm going to say, oh, sorry, that's not what I want to do. And actually, I don't want to type it off. And you don't want to watch me type it off. Let's put all this in. Right? Did you want to watch me type all that?
I did.
On my crappy little Surface keyboard. Okay, so what am I doing in this function, right? I'm switching on a variable called month underscore. Okay? In this function output, have I created a variable called month underscore? No, right? Everyone good with that? I have not created a variable. But month underscore is where? Where is it located?
The class.
Right, it's part of the class, right? And guess what about output? It's also part of the what? It's also part of the class, right? Because we said day of year, colon, colon, output. We said the output function is part of this class. Month, as a variable, is also part of what? Day of year class. And if you're both part of the same class, you have access to all the data of the class. We say you have access to all the members of the class, right? Output is a member function, right? Month and day are technically called member names. I don't care if you really remember that or not, but they're not technically variables, right? Because it's a blueprint, right? They're placeholders for variables. But month and day are members, output's members, so you have access to them in any function that is part of that class. And we go to that concept. If you really want to drive the point home, you could also, although it's just extra typing, you can also say this arrow month. That basically says this object that I'm currently in, right, use its month. Okay. I don't know if that's helpful to you or not. I'm going to start doing that in my algorithms. One class. All right. You guys are adults in this class, right? So we're just going to say month. And so depending on the month, right, and we said, right, kind of on the board, we said that month will be 1 through 12. Right, so depending on the month, we're going to see out January, February, March, April, May, June, July, what happens. Okay. All that translation's happening in my output function, and it's only going to happen once, right? Because I wrote it in the function. And then I'm going to see out a space and a day underscore and a new line. So every time I call output, it should output the data values of my object, right? And in a nice format. Month, space, day, right? There's no year, so there won't be that.
Does this only work for public numbers? Is there something else that you have to do?
Access to the variables works for public or private, and we're going to get to public and private. Access from the outside, that's where public and private really come. All right, let's make some days of the year. So in main, we'd say day of year, right? We'd say today, we could say yesterday, right? And once again, this is going to create two objects. One called today, right? One called yesterday. Right? They are distinct objects. They both have the same names for their data points. Right? They both have a month underscore and a day underscore. Right? But they're each distinct, right? They have their own, right, possible values. Both of them to start though, because they're both integers, what do they start with? Garbage, okay. So right now, and let's just do it because that sounds like fun. Right now, if I said today dot output, remember we access members of objects via the dot operator, right? So I'm going to do that, and then let's run it. Don't worry, I know you see nothing. We're going to build it. We're going to run it, right? And there's my day of year, right? Remember, my switch had no default. So if it wasn't 1 through 12, it's going to break, right? We're not going to get any output for the month, and then the day with some garbage on. So that's a problem, right? But what can I do between? I could say today dot day or month underscore, right? I don't even know what today is. The 30th? I'm sorry, the month's not the 30th, it's the 9th. Today dot day underscore equals 30.
Cody.
What? Toadies? There we go. And then if I build that and I run it, right, now I get nice output, right, September 30th. Make sense? Right, currently I access, right, all of the members via the dot operator, right? Today.month, today.day, today.output, right? These are all members of the class day of year, right? Today is an object of type what? Day of year, right? Which is why they have access to those things. Questions so far? Good so far? Right? Remember, output is technically called a member function. 1, 2. Right? It's a member function. Right? And technically, month and day are called member names. So let's add some more functions, right? And these functions can have all the attributes, although I probably shouldn't use the word attributes, but they can look like all the other functions that we've created, meaning that they don't have to be void, right? They can return a value. They also, right, in the parentheses can have any number of input, right? 1 parameter, 2 parameter, 3 parameter, right? They could be overloaded, meaning they have the same name, right? Any of that kind of stuff. So I'm going to write a couple new functions, one called input. All right, we're going to say int month, int day, right? And another one called get the month. Right. Input's a function, a void function that takes 2 things for input, right? Get the month is a function that doesn't take any input but returns an integer, and you better guess and believe that it returns an integer. That's the month, right? It's called get the month. Right? Does that make sense? Everyone good there? Right? Should we write those functions?
Yeah, just copy.
Yeah, right. So we're going to copy them. All right, we're going to paste them below. Right? This is the monotony of, right? Regardless of what they do, you always do the same thing to them. Change the semicolons to what? Curlies. And put the class name before the function. Right? All that is just set up so that they actually are part of, right, the day of year class, and also you can now write definitions inside. So let's talk about day of year for input, right? We're going to talk about this after I write it. So this is usually where students get confused when all of a sudden we have things that like This is month underscore. I have a month underscore here, but I also have a month without the underscore. All right. So let's talk about what's happening. What are parameters? Besides the things in the parentheses, what do?
Your input, right?
Their input. So it's data coming into a function. Agreed? Right? So that data comes into the function. We talked about scope, right? How long functions last, right? When they get called, they start. When the function ends, they go away, right? And all the data associated with it goes away. Everyone good with that concept? So parameters are input, right? Which means month has some value and day has some value. At this point, we don't know what those values are, right? We just know that it's an integer, because we said it was an integer. So we know that it's some value between negative 2 billion and positive 2 billion. Good with that concept? All right? But when this function ends, what happens to month and day? They go, they get erased, right? So they go away. So they're temporary, right? It's input for the function, but when the function ends, it's done, right? Which is fine for regular functions, although a lot of times with regular functions, we want to return some value back out. Because we probably did some amount of work, and now I want to get the data back out. Class objects, they work a little bit different, because when a function ends, the object doesn't go away, so the object still has value, right? But all the object's data are in variables that end with a what?
Underscore.
With an underscore. So anything that you want to save, right? Anything you want to persist beyond that function, you have to put into what variables? The underscore variables. Okay, anything that you want to persist. Which is why the assignment statement looks like this. Month, which comes from the parameter, right? It's input into my function, gets stored into what?
Underscore.
Month underscore. Month underscore is the data of my what? Of my object, right? So I take this temporary input, the parameter, and I store it into my underscore variable, which is the data of the object. It will persist. Does that make sense a little bit? Which is why it's always what? Parameter assigned to underscore variable. It's never underscore variable assigned to parameter. You want to take the temporary data and store it into the permanent data spot. Does that make sense a little bit? Also, month and day only exist in what function?
Input.
Input. So down here and get the month, can I return month without the underscore?
No.
No, because there is no variable inside of this function called month without an underscore. And there's no variable inside the class, because get the month is part of the class. Right? There's no variable in the class called month without the underscore. So if you're going to get the month, it has to be in month underscore, which also happens to be your what? Persistent data. Right? So it makes sense that that's the data you want to work with, right? When you're working with the object, you're always working with the underscore variables. That's where your data is located. You can take parameters and store them, right? Which is what we did in input, right? We took the parameters and we stored them into the underscore variables. Does that make sense a little bit? Anyone want me to go over any of that again? So what can I do in main, right? So in main, I could have said today.month, today.day, today.output. I could also do yesterday.input, right? And yesterday was 9/29. Just another way of putting data into my object, right? One way was directly inputting via the dot operator. Another one was using a function via parameters to put the data in. And that will, what? That will jump me from here, right, in main, right, and go all the way down to the input function, which means month is 9 and day is 29. So on line 69, we take 9 and we put it into month underscore. Who's month underscore? Say it louder. Whose month underscore are we dealing with?
The class, right?
One of the objects. So let's go back. Good, right? Because in main, what did I call input on? Yesterday, right? And so down here, right, where it's like, okay, month underscore, which, right, month underscore am I dealing with? I'm dealing with yesterday's. Right? So yesterday's month underscore gets the value of 9. Day, whose parameters value was 29, right, gets stored into yesterday's day underscore, right, which was 29. And when this function ends, month and day go away, but month underscore and day underscore as part of yesterday, they stay, right? That's my persistent data. Does that make sense? Does it make sense why sometimes we say this arrow, right? In this case, this would have been yesterday, right? Yesterday arrow month, right? Whose, right, object are we dealing with? It's a hard concept, right? Because when you write the class, you're not dealing with any objects, right? When you write the class, you're dealing with the blueprint. When you start writing in main, you start creating objects, right? And basically passing those objects automatically into all these functions. Okay, you have to separate the two when you write. Questions there? So now I could do something like yesterday.output, right? I can also say cout, right? Yesterday.get the month. No, get out. There we go. And if I run those, all right, we get September 29th, that's yesterday. And when I get the month, what do I get? I get a 9. Right? It is interesting, right? Because when I output, I don't get 9, I get September, right? That's all happening behind the scenes. Right? Get the month is giving me the actual integer value that I might want to do something. Questions there? We good so far? Okay, what's a problem so far that I've introduced into my program? Or maybe what assumptions have I made about people using my class?
You're assuming somebody would put the month and day correctly?
Right, so I've made the assumption that someone will put the month and day correctly. I'm assuming that when they say today.month and today.day, that they give me values that make sense for my object, right? And part of making objects is to make sure you always have values that make sense. But if I said 19 and 300, does the program still run?
Yes.
Yes, right? So if I run it, still compiles, still runs, right? But right, the output didn't make any sense because the date given, right, was not good days for, or dates for a day of the year. Does that make sense? And because we're the ones creating the blueprint, we want to make sure the blueprint never has stuff in it that's bad, right? That's incorrect. All right, and we have the ability to do that. And the big way we do that is the concept of encapsulation. All right, and so when we talk about object-oriented programming, there's encapsulation, there's inheritance, and there's polymorphism. Right, inheritance we'll get to by the end of the semester. Right now, we really just care about encapsulation, where we take pieces of our class object and we encapsulate them away from the user. Right, we protect the data of my object to make sure that we never have data points that don't make sense. Remember the two words we use? No? What words do we use for encapsulation to protect things? I have one of them right here. Public, good. And the other one is?
Private.
Private. So in C++, we put them in their own sections of the class. Right? Public, private. Public being the things that you can access directly via the dot operator. Private being things you cannot access directly via the dot operator. So you'll notice that all I did was add on line 11 private colon. And now if I go to compile, right, it doesn't compile anymore. And what does it tell me? It says on line 13, month underscore is what?
Private.
Private, right? And on line 14, it says day underscore is private. And it tells me on line 21, and on line 20, I tried to access those variables, but they've now become what? Private. So I do not have direct access to the variables, which is good because day should not get a value that is what? 300. So I cannot directly give it that value because I've made them private. Does that make sense so far? Okay. Which means that I have to now, right, only use things that are what? That are public. Which are what? Output, input, and get the month. Okay? These are the only ways to mess with the data of my object. They also happen to be the behaviors of my object. Okay? Functions. So now I can't say month 19th and day 300. How do I get data into my object? What do I have to use?
Functions.
The input function. Good, right? So I would have to do what? Today dot input. Agreed?
Yes.
But can I still do 19 and 300?
Yes.
I think so. All right. Does it compile now? Yeah.
Yes.
Run it. All right. So can I still get bad data into my object? Yes. But that data comes in via a function, and can we do things in the function to make sure that I never have bad data?
Yes.
Yeah, right? And pretty easily, I would say, right, to do that. All right, so let's look at my input function. Right? Right now, we're just making a straight assumption, right? Whatever month they give me, store it. But I could say what? If, right? If month. Now the question is it month or is it month underscore?
Just month.
Why is it just month?
Because that's where the input's coming from.
So that's where the input's coming from, and I'm checking the input. Okay? If you write your if statement after you stored it, which I don't recommend, right? Don't store stuff that shouldn't be stored. But if you do it after, then actually it doesn't really matter. Right? Because they both the same values. You store the same. Right? But so month has to be greater than 0, and what?
Less than 13.
Right, it's less than 13. Right? So if I do that, then we're all good, right? Then I can say month underscore equals month. Right? The else would be the incorrect, right? And maybe let the user know, right? You gave an incorrect month. Right, setting to 1. Right, and then once again, month or month underscore, set to 1.
Underscores.
Right. Does that make sense? Right. So that's one way of doing it. This actually isn't the way I like to do it, where I'm actually checking for what's correct, storing, and then otherwise that, right? And so I'm going to show you the other way that I would do it. Right? I basically fixed my input. It saves me an if statement, which I like. So for day, I'm going to do it from the negative, right? What's incorrect. So if day is less than 1, or day, and notice it's not the underscore, right? If day is greater than what? 31? Are we good? That's incorrect. So if day is less than 1, or it's greater than 31, that's not right. Right? See out. Right? You gave an incorrect day, setting to 1. Right? And then in here I just fixed the day. So now I say day equals 1. Notice I do not say day underscore equals 1. I actually fixed the input. So whatever the user gave me that was wrong, right, the day without the underscore, I've now made it correct. So if it was wrong, I've made it correct, and then the next line I'm going to take the correct version or the original version, right, whatever was correct, and store it into my underscore. Does that make sense? I like to attack it from the negative because then I don't have to write my if else. I can just write a simple if, fix it, and then always store, right? Because you're always going to store in this function. Right? You're always going to take a parameter and store it into your underscore variable. It's just whether or not the parameter had the right values, or if you have to, right, change it, which I just did here, to give you the right values. Does that make sense a little bit? Okay. Let's see if it works. Let's save it. Let's run it. Right. Incorrect month, set it to 1. Incorrect day, set it to 1. And now we get what? January 1. Right? So there's no way for my day of year object to ever have values in it that are incorrect. Right? Because we've made sure that the only way to access the data is via my public functions, because we made the data private. And then in that public function, we made sure that we did a check to make sure that the data was. Does that make sense? Right? There's only one other time where the data is incorrect. Where would it be incorrect? Anyone know? We said when we created my object, what values did it have? Garbage, right? So it could be on initialization, right, that we have bad values. We're going to fix that on Wednesday. Right? That's your plug for show up to Wednesday, right? That's where, remember, constructors come in, right? And so we'll add constructors on Wednesday. I'm pretty sure we're doing that on Wednesday. Questions? All right, so let's talk about one more big concept, and that's the idea of accessors and mutators. Sometimes you hear them called getters and setters. Okay. Now that my data is private, the only way to access it is via functions, right? And so because of this concept and because we always make our data private, these functions have special names, and we call them accessors and mutators. Okay? Accessors access the data, right? They get the data. So accessors basically look like this function here called get the month. Technically, this is an accessor, right? It gets the month, right, which was an integer, right, and returns it. A way for you to get that data out of your class object. Because the data is private, right? So we have no way of getting it unless we write a function to get it. Mutators mutate, change the data, right? So mutators take data in, check it to make sure it's correct data, and then store it. So mutators look a lot like my input function, right? The only difference is that mutators and accessors only ever work on one data point at a time. So where input dealt with month and day, right? Get the month, my accessor works on just 1 month, right? Setting the month would also work on just 1 month. So you want to have a mutator that sets lots of things. So it's this 1-to-1 correlation. In fact, it's a 2-to-1 correlation, because for every data thing that you have, you would have one accessor and one mutator, right? So we will get 2 functions per data. Which means for this one, how many functions am I going to write? 4, right? Because I have day underscore and month underscore, so I'm going to write 2 functions for each, right? 4 functions. All right, let's take a step back and think about this for a second, right? Because we always just teach you as professors, instructors, we always say, right, every data point, write an accessor and a mutator. Everyone good with that, right? You've probably heard us say that before. But really, right, even though that's what I'm making you do, that's not necessarily what you will always do. Okay, there is a reason why you made the data private. Okay, everyone good with that? There's a reason why you made the data private. It may be that you don't want the user to ever change that data point, like directly change it. Right? So you don't write in a mutator for it, because you don't need them to change it. There are times when you don't need the user to know the value of that thing. So then you don't write an accessor. Okay? So you only write accessors and mutators when you think they're useful, when you need them. For now, it'll be, always write an accessor and a mutator. Right? But I want you to think about the fact that even though that's what I'm telling you to do, doesn't mean that's what you always do. Okay? You write accessors and mutators when you want the outside user to have access to the data or have access to change the data, right? The ability to change it. If you don't want them to have that, then don't write them. Does that make sense a little bit? All right, so let's write some accessors and mutators. For me, in my class, they'll always be named the same thing. All right, and so I'm going to kind of show you that structure, and then we'll go from there. All right, so there's some member functions, but now we're going to write some, right? They are functions, so we're going to write them in the function section. We're going to say accessors, and then we're going to say mutators. All right, accessors always get a data point, right? So accessors will always get, in this case, either month or day. So they always have a return type, and the return type correlates to, right, what it is that it's returning. So the accessor for month is going to be int month, open close paren. The accessor for day is going to be int day, open close paren. You'll notice they're named exactly like the things they're trying to access to remind us that that's what their goal is to do. Basically, we just took the underscores and we changed them to what? Parents, right? We took member names and made them into functions. Does that make sense? It's always the same. If this is int foo, then the accessor is what? Int foo parent, right? Pretty easy to hopefully remember. And they're written that way to remind you that if you want to get that data, it's private, so you can't get it, but you can use the accessor, right, which is named the exact same to get that value, right? This does not allow you to change the value, right? It just allows you to get the value. I'm going to get rid of get the month because it already is basically an accessor that we wrote earlier, but I want to do it in the right thing. So now I'm going to have a function called int month that all it does is return month. And then we're going to have int day of year, colon, day, right? And it's going to return what? Day
Underscore.
You'll see accessor functions aren't crazy. They're always the same, right? Take whatever the data point is, make that the name of the function, and then return the data point, right? Always, right? They don't do anything special. It's always whatever you're getting, just return that. Return foo underscore, return foo bar underscore, return lovely cupcakes underscore, right? Whatever that you want to return. Questions on accessors? Oh.
Why would you not capitalize this function?
Great question, right? Because all my other functions are capitalized. My style, maybe you'll agree with it, maybe you won't, but to remind us that here we're working with basically raw data. Whereas all my other functions are going to do something, here I'm working with one single data point. And then mutators are not about getting, right? So these would be called getters by accessors. They're called getters. You'll see that in literature as well. Mutators are all about setting data, so they're called setters. They're always void functions. They're always set, underscore, and then whatever I'm going to set. So set month, int month. All right? And then void, set day, int day. You'll notice it's not what? It's not month underscore, it's not day underscore, right? Month and day here are parameters, right? Notice those parameters, both on lines 14 and 15 look a lot like the parameters on line 9, right? These are just single ones, right? I'm working with just a month. I'm working with just a day. Questions there? Right.
Why don't you work with both of them on one mutator?
Well, because I might not always want to set the month and the day at the same time,
Well,
right?
you could have passed in like a null and day.
Yeah. I mean, you could do some default arguments maybe, but not in the right, not in both orders. So mutators are all about changing one data point, whatever data point that is.
Oh.
All right. So, right, set month, right, day of year, set month. What do you think I should do in this function? It's supposed to set the month, right?
Yeah.
So setting really means that the underscore variable should get the what? Everyone agree? All right, set day, day of year, set day, right? And then day underscore equals day. Guess what? All mutators look the same. Just like all accessors look the same, right? Accessors always return the underscore variable that they're accessing. Mutators always set, so store into the underscore variable what they're setting. So it'll always be day underscore equals day or foo underscore equals foo, right? But bigger picture, what's happening? A day's coming in from the outside, right? Outside for us, you could think user, right? I mean, it can come in from anywhere, but you don't ever trust data from the outside, agreed? Right? Because you can never trust the user. But I'm taking that data and I'm storing it here. So I'm trying to give you a hint, right? I have not done everything I need to do in the mutator. What else do I need to do?
Check the data.
Check the data. You like we've checked the data before, right? Agreed?
Yes.
Right? Up here, right? So I'm going to steal this code, all right? And then we're going to talk about that. And we do that, right? I'm actually going to steal for this because I just like doing it this way better. Right? If month is less than 1 or month is greater than 12, you gave an incorrect month. Right? And then we'd say month equals 1. I don't know if anyone's ever told this, but when you find yourself copying and pasting a lot of like logic code, what should you have instead?
A function.
A function. Okay? So if you find yourself copying and pasting a lot of code, think this should be a function. Right? How am I going to make this a function that works? Okay? What does that month do?
Sets the month.
Sets the month. What does that day do?
Set the day.
Sets the day. What does input do?
Takes input from somewhere.
Takes input from somewhere and sets what?
Month and day.
The month and the day. So could I use my mutators and input instead of writing my if statements in both places?
Yes.
Maybe. All right. This code that I've highlighted in input, what does it do? It sets the
Month.
month. Agreed?
Yes.
So can I just say set month? Pass in month?
Yes.
Is that allowed? Input is part of the class day of year. Agreed? It's a member of that class. Is set month also a member of the same class?
Yes.
So can you access members from other members of a class? So yes.
Yes.
Yes, that's the whole point of classes, right? Everything in the class has access to everything else in the class. Whether it's public or private, it doesn't matter. You're part of the class, so you have access. Right? So what's set month going to do? It's going to take the month given from the user and send it over to this function. So this month will be the one that we got from the user, and at the very end, it's going to set the month. So when I get back to input, what's happened? Has the month been set?
Yes.
Yeah. What about for day? What could I do? Okay. Have I duplicated my logic, or have I used a function so I didn't duplicate my logic?
Use a function.
Yeah, the second one, whatever. It was wordy. It didn't sound good. Okay. Whatever that second one said. Right? Notice how short input is? Isn't that cool? Right? Utilize other functions you've written, right, to make your life easier. Right? When you start writing code and you're like, I feel like I've written this before, right? Use the function that you've already written to do the work for you. So my input function, right, now just utilizes my mutators. Because my mutators have the logic in one place that hopefully is correct. And if that logic's incorrect, and I need to fix it, how many places do I need to go to? One. The way I had it before, remember I copy and pasted, if that was incorrect logic, I would have had logic incorrect in how many places? Two, and I would have had to remember to update it in how many places?
2.
Which, right, once it gets to 3 or 4 or 5, it's going to cause you problems. I mean, maybe not you guys, because you guys write perfect code every time, but for me, it causes me problems.
That's a
Right.
log.
What?
That's a big log. You can't write code perfectly.
I know, right? Does it make sense a little bit? Everyone kind of see what I'm trying to get you to get at here?
Yes.
Okay. So now in main, right, I can still use input, right? But I can also do things like yesterday dot set month, right, and pass in 9. And yesterday dot set day and pass in 29, right? I can use my one function that does everything, right, the input function, or I can parse it out into, right, the smaller function. And hopefully this will still work. I wrote it correctly, right? Oh, I still have my incorrect month, but that's fine. January 1, September 20. Make sense a little bit? Questions on the structure of how we set up accessors, mutators, all that kind of stuff. Right, named after, right, the variables, right? Mutators have set underscore before them, right? Accessors don't. So you'll see me, right, in future labs or future assignments say create accessors and mutators, but I'm not going to say this is the name of the function, right? And so my expectation is that you know that you just name it the same, right? as the thing that you're accessing or the thing that you're changing. All right, one last thing, and then I'll let you build a what? Remember? Spaceship. You get to build not a rocket ship, a spaceship. Which has more meaning. I mean, maybe not to you, but I have small kids, so they like the Lego movie, and there's a character that always says, like, he wants to build a spaceship. Maybe I'll show the clip later. But anyways,
We built a snowman.
this was before. No, we're not gonna build a snowman. Okay. I don't want to. All right. Although there is a second movie coming out of that. So. All right. Disney's so good at just creating one thing that they think's good and then milking it for as much money as they can.
You mean Star Wars, right?
Well, yeah, exactly. Well, I mean, all sorts of things. It's good, right?
I wouldn't say Star Wars. Just
If you can make a limitless amount of money off of one idea at one time, why would you not? Right? I'm in.
Mickey Mouse is so insidious.
What do you think he's doing right now?
The House of Mouse. Are those Mickey Mouse even in anything anymore?
He's gonna be in episode 9.
Oh yeah.
It's going to be the Sith Lord.
He's gonna be the Sith Lord.
He's gonna and they'll come out that he was behind it.
He was Plagueis. He was Plagueis. He was manipulating everything.
All right. I have more to talk about, and then we're gonna go on. How's that sound? So a little bit of a recap and a little bit of something new, right? We talked about it's good to make member variables private. Why do we make them private? Because we can't trust the user. We could. Great. You know, we can trust the user. None of us would ever have passwords on our computers. Right? It would be great. None of our financial stuff would have passwords on it because we would trust everybody. But we can't. And so we have to do things to protect ourselves.
I mean, the only way a user can change their data to begin with is if we involve them, right?
Right, but the idea of a class is that we make a blueprint that anyone can use.
Like any program.
Any program can use. And any programmer could use as well. Right? I mean, and if you gave them your source code, they could go in and change your source code, right? But basically, you're going to make something that's going to work and have it always work. I know. It's a weird concept because I'm having you write, I mean, today it won't because you'll just build the spaceship, but a lot of times you write the code to build the spaceship, and then you also write the code in main to build the spaceship. Right? So you write the blueprint, and then you write the program. But a lot of times, people write the classes, and other people implement. So like we've been using strings all semester long. Someone wrote that. We've just been implementing it. But a lot of times we have to write both because we're learning. Like today, I've written the implementation. So I'm using the spaceship. You're building the blueprint for the spaceship. So you only have to do one thing, not both.
So what you're saying is if we crash the spaceship, it's all not yours?
Yes. I wrote the command, build the spaceship, right? And if the spaceship crashes, it's your fault. I just followed your blueprint.
So you're putting your life in our hands.
Yeah, it's a little scary. It's actually more scary than I want it to be. All right, so memory will become private, but basically your class is useless if you don't have access to those private data. Agree? Which is why we write mutators and accessors, because if we make it private but we don't have access to it, what's the point? Right? It's like saying, come over to my house, but everything's locked and all the windows are barred and you can't get in. Maybe it is already that way. Right? And so the functions allow us to get to those member variables. Everyone tracking? A little bit of a review of what we did. Right? So those were my accessors and my mutators come in. Right? Am I good so far? I don't think I've gone far enough in my slides. Here. Let's go where I want to be.
There we go.
Yeah, this makes more sense. So this is something new.
Constant.
Right? Const, which I told you was going to show up all over the place this semester. Do you remember when I said that? Right? And const is all about protection for who? For you, the programmer, right? Make sure that you don't accidentally change something that you're not supposed to change. Okay, and this can apply not only to variables, but they can also apply to class objects or functions inside class objects. So that kind of seems weird. A function that is constant. All right, let's talk about what that looks like. All right. So member functions that don't need to change data, you can mark as constant, meaning that they cannot change the data accidentally, right? Because const is all about stopping users from changing data accidentally. All right, so I'm not gonna give you the answer unless you're on the slide, right? But which member functions should not change data?
Accessors?
Accessors, right? Because accessors get data, mutators change data. So we don't want accessors to change data because that would be wrong, correct? Right? So if we put const on the prototype and the definition of accessors, it will prevent that function from accidentally changing the data of my object, which is a good thing. So here's my something class. Isn't it so lovely?
Something.
Right? So here's my data, right? It's what? Private. So I write accessors and mutators, and I would have a mutator, but my slide couldn't fit it, right? So here's an accessor. You'll notice that the accessor is named exactly as the data, right? Just instead of an underscore, it's a what? Parens. And then a new place for const, right? I feel like you're going to start writing something like, where am I going to put const? I'll put it here. No, it didn't work. Here, put it at the end. Oh, it worked. Yay. Right? So, right? That's how you code anyways, right?
You just
put a
guess.
semicolon here. Crap, that didn't work. Put a curly brace here. Crap, that didn't work. What am I supposed to do now? I don't know. I should have paid attention in class. Right? It also shows up in the definition, right? Class name : like normal. Right? It's kind of weird. There's my paren, there's my open curly, and between that, keyword const. Okay? And basically, we've said that this function is a constant function, meaning that it cannot change any of the data of the object. I'm going to say that again. It cannot change any of the data of the object. In that function, you can create variables. You can change the values of those variables. You can do everything that you want, but you cannot store anything into an underscore variable because those are class variables, right? So any of your underscore variables, you cannot change because you said the function was what? Constant. Does that make sense? And the functions we put constant on are the functions that we don't want to accidentally change stuff, right? You like write the description of it and you're like, yeah, this function should not change data, right? It's all about getting the data, right? Making it look a certain way for the user, right? But it should not change the original data, right? So we put constant on it. So you get compiler errors, right? This is also key. Constant functions can only call other constant functions. So there's no runaround where I'm in a constant function and then it calls the input function which changes data. Right? Once you're in a constant function, all of the functions it calls also can't change data, which means they also need to be constant functions. Does that make sense? All right. So let's just add const on my program. All right. And so the ones that should be constant are what? Month, right? And day. Any other functions should be constant?
No.
That's incorrect. Try again. Output. Output, right? Why should output be constant? It's outputting things, right? Should the output function actually change month underscore and day underscore? No. So we make it constant as well, right? It's kind of annoying to add it afterwards because now I got to go down to each function and do that, right? Const. And const. But if I do that and I do it correctly, right? Notice that program still works exactly the same, right? I added the const word a bunch of places, but it still compiles, still does everything that it should have done. But the key here is that in this function, you didn't actually say day underscore, right, times equals 2, right? This says, right, take the data, right, in day and make it twice as big. Which obviously you wouldn't do that anyway, but maybe you would. Right? So I compile it, and what does it say? Assignment of member day underscore in read-only object. Right? And really what that's saying is that you're trying to change the member variable in a constant function. And that's not allowed because you said it was read-only, which it is. Does that make sense? And so like in my next assignment, oh, another assignment? That doesn't start till next week, don't worry. right? But in the next assignment, right, you'll have functions, and some of them will say this is a constant function, right? Which means you put the const keyword on the end of the function to protect. You might say it even in today's lab. Maybe. I'd have to look it up. Questions about classes? So next class we're going to talk about constructors. Maybe that's all we're going to talk about. I don't know. Right, but not a lot. We're going to talk about constructors. So when an object is created, right, what does it, right, what happens and what can we do in that moment? What's today's lab? Is today's lab 9? That sound right? All right, build a spaceship. Let's see. I was going to see if I could give you some hints about today. I think one of the hints is you're not going to use the dot operator at all today. So please don't use the dot operator. Okay? The dot operator is used not in creation of your blueprint, but in the actual implementation when you like write main, you create an object and you do stuff with that object. Right? Because I wrote a unit test, you're not creating the spaceship, you're creating the blueprint for the spaceship. So you're not going to use the dot operator, you will use the double colon. Right? So let's look at the data of the spaceship first. Right? So your spaceship can have a name, a top speed, a fuel source, and a crew capacity. All right? So that is what your spaceship can be, which means that you're going to have an accessor for name and a mutator for name. An accessor for top speed and a mutator for top speed. So that's 8 functions. And in fact, when we look at them, right? Here's mutator, right? Set name, set top speed, set fuel source, set crew capacity. 4. The name, top speed, fuel source, and crew capacity, right? 4. So 4 accessors, 4 mutators. Do you notice the accessors are what? They're constant, right? Because they shouldn't change the data of your object. And then 1 output function, right? 2 string, which means you're going to need to use a what? String, right? We're going to start, right? We've written a lot of like output functions, which always output to cout, right? By writing a 2-string function, which is basically like an output function, but as a string, it gives us a lot more ability to do things with it. Because I can see out the string, so I can always output it, but I can also, right, store it somewhere and do something with it. A couple things that trip people up. \n means new line, right? Notice, is there a \n at the end here? No, right? So in that 2-string function, the string should not end in a new line. Okay? And then it says some things about top speed should be set to 2 decimal places. Remember last week we did right, dot precision, dot set f, right? So you're going to do that on your string stream. Use your underscore variables. Today's lab shouldn't be, logically, it's not hard at all. Okay? Logically, you're not really doing much. Structurally, right, you're practicing how do we take, right, functions in a class, right, and implement them below main, right, changing the semicolon to curlies, adding the, right, class name, spaceship, colon before. Make sense a little bit? Questions there? All right, so that's what we're going to work on today, right? Also, assignment 2 is still due on Thursday. Okay. Some of you, anyone want to brag and say they completed it? I completed it, right? How many lines of code did it take you? 25. Not a lot, right? So once again, it's not a lot of code. But don't take that as it's not going to take you at least a little bit of time. Okay, it's still going to take you some time. So get started on it if you have not already, right? Ask questions when I'm available, right? Not at 1 in the morning, right? So I can help. Usually not. Normally, sometimes I'll be up late and I'll see someone's email. I'm like, oh, you poor soul. And then I'll go back to whatever. Take a little bit less out of it. Exactly. I'll talk to you tomorrow. Might be able to do that.
Depends on what it copy all ones from previous ones. Then I copied all the others. Yeah, and then I went through and I sat well, I was writing them. I wasn't using all the other. So this was huge. It was pretty much all these. I think this is the full list. I just copied the whole thing over, wrote out all the code, and then erased it. Yeah. You have to.
This is the motivation I'm gonna give you today.
Oh, great.
Sorry, I didn't feel stupid.
Yes.
So there is a unit test.
Yes,
So the new plant does. Oh yeah, there's the funds. Yeah,
So
these
you
are-
said that.
So that's all right, you in Hawaii?
I mean, either. Guatemala. How do you say it?
But that's still not gonna give you enough time.
I was like, I'm Hawaiian.
No, it's going to be like.
I get it, I don't think I got switch my phone.
Well, no, you have
Yeah, based on my local visual one, that's how I use Razor.
Yeah. You can set from
If you can, that would be cool. That's what we did. Count, building. Location. See, yeah, there's no way to do it. No, we gotta change your, yeah.
I didn't want to add. Yeah.
I just wanted to just make it shorter.
If I added that. Yeah, either. Well, the issue I was coming up with was, it would probably say this problem will not open, but it can also. It works. It works. Technically, you know, instead of
Oh.
Oh, no, I'm just. I was just going up with this. It's like, okay, and then it's like. Oh, that's not what it's even. Oh, no. It's more science. I know, but you're gonna use it in that's an array of strings. Even though it's technically something.
My GPU is special. But CPU, CPU. I know you brought your IBM, technical IBM.
So the idea is, the first thing you do is you want to start checking the answer. So the name of the typing is not. If you want to start it, you want to start at one. You start from your that's
going back. Do you make a whole time in May?
So like,
When you say
you
you
do it all.
Okay.
It takes whatever it's sees it out right next to it, and then you don't even get it. The other thing you're supposed to do is if you feed it a file name, so this is instructions. If you give it the wrong file, it should give you an error sound that can't find the file. If you give it the right file, it'll actually print out the contents of the file.
So, understand that. So, certainly, so, I would like the step statement to go through.
Right, you don't need a statement.
Would that be like the valid form?
You don't need the for. So, you technically need two. There's only two real, so the first thing that happens is type in the name.
Have like two yesterday.
Too much. One extra argument, two extra arguments. That's gonna be a total.
Yeah, there's no protection there.
Only gave you the name, right?
Okay,
You
yeah,
have
we
two
got-
functions you want.
Yeah.
So basically, our CI is just a number of arguments, and no matter what, because typing the number is so if they add an additional file, like how I did instructions is the second argument. If I just do cat by itself, technically the only argument is cat.
Yeah.
So that's either 1, 0 additional. If you type it all out, if you're adding one
But no, that's
additional,
great because this
right?
dumbass.
And so you're basically shouting out no additional arguments, and your number of arguments.
So like number of arguments we,
This guy at the
like
very
files,
end, he's saying, I put him for the
Basically, just think of arguments, it's just the words here separated by space. So cat is one argument, instructions is the second argument, or space. Choose the second argument. Or, yeah, or technically it's the third argument, but I'm not counting cat. But see what I'm saying, so technically 1, 2, 3 arguments, so choose would be the third argument. When you do it,
But
it's
no, and,
the first one is can't find the the second one is cheese, can't find cheese.
yeah.
So, okay, so that's what argument C is. Arg B is an array of argument.
Yeah.
So it means that it's an array.
Yeah, I'm gonna go look for one.
Picture it. It's an array with a string to a string.
You look at that one?
Picture it, but basically, so the first slot in that array is 0, right? The first slot is always going to be cat. The first slot in that array is always cat. The second slot is only going to be populated if they type it in. And it's actually denoted here. So if there's only cat with nothing else, or C is 1, this will only have one thing in this array, that is 0. So yeah, so basically this is instructions are TXT. Argument at index 1, which is 0, 1, 1 is the second slot, would be this instruction TXT. And so that's where your for loop comes into play. That's only going to be if there's more than one argument passed in.
So, you want to chat, so first one.
So,
and the for loop is obviously, it's similar to other arrays, you know, you use a for loop because we can go through an array and see what's in it. By starting with 0, increment that by 1, and so on. You do the same thing, but you only do that if there's multiple things.
So I'm assuming we, like, we definitely need to. To actual
Correct. You don't need the upstream, downstream, but you do need the
I'm trying to remember.
that. You don't need to create the upstream.
So what the pipeline,
That's what they named it. That's by convention is a good idea. But yeah, you're creating an input file stream. Say those words out loud. Named pin, and this is going into RB into that file. Right? And I'm only allowing that to happen if RC is or later than we want. Because it's one class.
I think that's.
not necessarily.
It's kind of hard to have the concepts, but once you can.
Yeah.
It's not a lot.
I'm just familiar with how to use it. And
That's what I was thinking about. So on the practice exam, it has like two. I don't know if it's great separation. I know.
Same loops, pretty much the same structure, just different.
It's just defined differently.
This is where you're at that one.
So technically, that's still separation.
That's what we.
That's why they're not messing that.
That's why that's. I don't know.
Like the big south.
Or another state.
Right.
So once this goes through, here's this file. So what's the
Also, I was gonna say like, oh, because you said you're checking these cases. Maybe actually. He did it 44
Yeah, so you'll try to each.
So that means I can copy paste and reuse it, so.
Okay, I put that over, what I did.
Yeah. But don't put all this around it. Just
Not read his handwriting.
Okay, and how I. Okay.
The street shape's not here, it's only coming in behind 6
Okay.
Alright. Today's all about structure, the logic, like, all the functions are super short.
Can you get back in? Can you get back in? Oh. Is it easy?
First, it's like,
Oh, so, yeah, you're basically, no, so you, when that happens, that basically and then it gives you an.
I think I've flunked.
So.
No, I had two late.
Seeing whatever.
Then I can have another.
Or no, it's from you, it's just failure without.
Yeah. And then not. Or early withdrawal.
Okay. Oh, you know what, you want to get one. Because the problem with your that operator, your seeing that operator, it only pulls to the next white space. So there is one argument, or no, if they type in any, like the whole sentence, it's only gonna pull the first word. You gotta do get line, not whole.
You passed me this morning.
Did I?
And I was like, I was speaking like, oh no, that has to be him. I didn't know it like you, and I was like, wait, something
I would
like, oh no, that's.
Or, no, sorry.
Yeah.
Not,
Somehow I did. Somehow I just.
Oh shit. Did I, was I speeding or no?
Oh yeah.
Yeah. I was speeding.
Let's go.
What can't a constant function change?
It can't change any of the data of the object.
I
This is all the
would
objects.
have a Miramon do after these.
Only the thing.
Otherwise, it'll just go order.
Yeah. So you can create new variables and change them to whatever you want, but they can't change that. In the blueprint.
Yeah.
Yeah, this is just.
should I fix that?
Oh, yeah.
Logically, like artists,
I was trying to remember how I raised it before.
Yes, that's correct.
In the past. This is basically like how the on did for the last 8, 7 months. Like just basic.
We're gonna post it.
This is. But I need to put the I in the system. It's probably the places that's where it's at.
Yes.
Oh, you're just, I see. I didn't realize what you were looking at.
Yeah, it's like.
Yes, that's what, correct, that's what we RP, or the bracket. No, you, items, you basically have to work things like,
Yeah, I did, but I didn't realize that I used to get
yeah, but that variable is only returned inside of that. Inside of that is still that one. So you can.
So as you do range.
You're correct, yes, you need additional.
You said I do use.
Yes. Or
So, dot slash name.
Yeah, you need to make it first.
Some reason that's kind of right. Typical, like, how
Just output.
only the definitions need the semicolon.
No, the definitions on it, just the class. Yeah, both. Inside the class.
Yeah, just type in you get like, make sure the first one. Or you just type something. That's what they should copy it. Or just like Control C. That's working. Now give it a file. Give it like 1.txt.
Oh, yeah.
So, I do this with
Good practice and really complicated C++. I set it on the screen.
Oh, okay.
So just see outside.
So technically you want your folder to start not at the file name, but at the second. So technically you want that to start at
I was supposed to.
Fair, my in general.
No, this is the first one.
Format or
So argument at I, it's not, it's a file name, it's not the file.
so the RC.
No, but, so the deal is, so what you're doing is you're outing file names, not what's in the file. But they, that's why it's not shown.
I'm thinking that like, one backpack.
Make sure it's outside of it.
Did you get that to work? Wow. Did you figure out where you're gonna get precision on the double? Okay. Yeah. Should try running that. 2.5 hours.
Well, then you give me the file.
Yeah, I was gonna do that, I wasn't sure, so you know what?
Yeah, we just had it.
I said you were, I'm saying that, like, this was just going to be like a file page.
Correct. Well, not even a file location, just a file name. RPI as a file name.
So the arcs in.
Well, no, so this doesn't have all, I don't see a lot of logic to that line there, at least in that spot. You're putting in an info stream, and you're passing it the name at the time, which is that line's right.
I thought you were supposed to.
So
Oh, so I really don't. This.
that right there, yeah, that line doesn't need to be there right now. I would control that, so just because you know me up there. Yeah. So, okay, so here's the deal. You're bringing, you're getting a file name. Now you're taking that file line by line, and you have to put that out to the screen. Now you can't really do that easily unless you create like a string and build that string so it's exactly like the file, and then output that string.
The string, like,
Or I just, sorry, not string, that is how I started, that's not how I used it. So, the string does have a string in mind what it is, but the idea is you're basically going to take one line out of that file, put it on the screen, take the second line out of that file, put it on the screen, until you see an end of file. So you're basically doing an operation all the way down the file, until you see the end of file. So you actually have to have a while loop.
so now the more loop.
You need a for loop. The for loop is going to go through your arguments. The while loop is going to go through each file, each line of each file. Line 1, line 2, line 3.
So for the for, the auger.
The for loop I want to change, because that's, the for loop is going through the file name. The while loop is going to go through, it's going to basically go through the file.
Is the while loop.
Correct. It's going to be incremental. So this is incrementing your file name. This is what you're doing with the file. Each file. So this is going to be an if while it's true, which what needs to be true is that you're not in the file.
So it's actually like this.
Exactly. Except the CN is going to be in the file. So your file, not your CN, but your file.
So at the.
While, correct, instead of CN, your file. So what this is basically while your file is not at the end, and then you basically want to pull the whole line. And run it all the way to the new transfer to the original. Yeah. And then you can store it in a string. A line can be a string. So you haven't created a string yet. Where this one was saying you wanted that. Oh, well, you already did. You already did something over it.
Yeah.
That's where I was planning on putting it. Right before we, yeah, so you're going to want to create a string. Just years ago, I would have a standard. What's it called? Oh. And then basically, you pulled out the line out of that string. But, what are you going to do? What did you say? Yeah, I know you're saying. You think they're tied to the same.
Yeah. No, it's just like always confused, I guess. Problems, program out, and always get reversed. Like, I'm trying to use that CN operation to say one month's work.
You're setting a position.
Business.
Yep.
I always forget that.
Yeah.
These are all going the wrong way now.
I thought it was greater than because you're storing it into it.
Well, because it's less than because it flows out. The way I look at it is that it's flowing out, so it hits this, it flows around. You don't want to capture it. So if you go to advanced IO, there's formatting. So it's the combination of this line, yeah, line 34 and line 40. So you both of those. So you don't do much, yeah, you don't want strength, if that's what you're saying when you see.
Trying to get the multiple line quantity movement to work.
Okay.
Instead of having issues, I'm not sure where the issue is. I use like if I was trying to make it so that it takes like it's supposed to take like the file names and from like output it.
So your for loop says I starts at 1 and then it says what?
I is greater than receipt.
Okay, so if you have 10 things, let's say 10 file names, I starts at 1 is bigger than 10.
No. So it's less than?
Yeah, right. When you count up, it's always less than. When you count down, then it's greater than. So that's why it's not looping.
But every time
Let's do it. I wish you would have stopped it from working anyway, so.
Oh, there we go. Okay.
okay, I got it more.
I broke my terminal.
You're making progress. You're making progress.
I can't type it in one.
Hit Control C.
No, but that's what this is doing. You're seeing up the variables where you're at. So I don't know why.
Do you have a for loop or while loop that doesn't stop? Because it's like a runaway while loop, runaway for loop.
No. I bet you would.
Did you not return anything in a function?
Ooh, I may have done.
Because if you don't return anything, it kind of breaks.
Void function.
Void shouldn't return anything.
Yeah.
What did the linker just back here has to do with that? Oh, it's just a link. Probably made time before.
think it's the time to have a state. We call it a seven stream.
Like I said, it was the same ability.
Oh, okay, wait.
Make sure you add your active. Access application. They want 6.0. It was at 6.
That work? So concepts and non-inference. So they go and non-set ones. The set ones are change things. These are accessors, but they get something. But I was
Oh. What do you do about this? That's what I did. I have to.
Here are accessors, right? They can your yeah, right. Here are mutators. Set the month, set the day, right? It's just like set right, you notice that all of these ones, they take the month.
Are we allowed to add using statements to lab, or do we have to use just what you put in there?
What do you mean, what's the problem?
Because I'm just failing one of the tests, and I think it's because the spacing isn't correct when you output the string stream.
Wait, I'm looking at
Wait, you have to set.
Well, if you want to do it this way, so outside of,
That's why it's
like, insertion
It has
operation.
to be formatted correctly.
Yeah.
So just, add the necessary spaces in here, so.
Running.
Yeah. So you could just have more spaces.
exactly the same thing. Well, not it. That's lower.
I have that too.
That's lower.
Not three.
God.
Something on this message board.
Which one, the last one? On two streams, yeah, you would print SS
Up
dot.
there and just copy and paste the 9 spaces. That might go. That's in between each one, you know. You know, I did that. It's like this, right?
We can't concept from I know, everyone has to, I mean, you have one.
You said spring, there's just parts of
Nobody will understand. Stairs for screens. Figure it out.
No, we got it, but we were missing the zero. So, that doesn't work. Yeah, that's that doesn't work. That means we're bigger.
You can do that, but you also need to do that.
Yes, how do we do it without?
Eyebrow, you could do two, right?
You know how to do that, you put the zero in there.
These are classes.
No, those are gonna be
If we go back.
mutators because you're setting the stuff. You're the ones that just want to read it or get We're on the
Or no, just show you.
Correct, it's gonna be set. The giveaway is the void.
Anyone else have?
Everything I do, it's not logical, it's a precision.
You get extra points for cheating.
The system, no.
I had that problem, but I fixed it. Yeah, I fixed it by looking at the class example in lecture 7 and look at formatting.cpp. Look at line 34 and 40.
Oh, hey, look at that.
Well, I would do this check. Right, but that's when you open the file.
I'm good, I said like that shit. You're
We don't move the file, but that's.
Okay, now I just have to figure out how to output it to the screen.
Feels so popular, guys. I'm always more popular when I'm terrible at teaching. Well, yeah. So if you're gonna use set precision, that one is part of the library called IMD. Outside of that, you could do it. Because really, set precision, you're only ever gonna set it once, right? So then, really, you just do that set stop. Because precision will set for everything. It's not a one-time thing. And stream is a stream. So.
Okay, then what about,
we might not like it, but we're gonna do 2 strings like this the rest of the semester. Like literally like this. We won't do as much of it.
what about converting from a string?
So at the end, you return, and you do that, and you do the CSCI. But don't call Spaceship because that's the class, not to get out. So usually you can just, you don't really need to store it between these.
That just turns the string.
That's the whole point of the string. That's why it's not supposed to be complicated. It's just like, make it, pretend like you're C-outing, and then boom, it's a string.
I convert or something, I don't understand.
I think it's gonna freak out because I think Spaceship was not a capital.
It'll freak out everyone. Thank you.
Okay, let me get that. Is it working out?
Yeah, I had it too. Oh, man, 26. But yeah, it was. So, but I get what you're working on.
What mix that up, everybody?
See, it's so terrible.
Yeah, I do we understand. It's because it's in the return. Right. But I don't know why.
No, 38, you're just gonna need.
Right, so at the end, the new line character is that. But basically it's saying that it's in the text file in Windows format and not Linux format. Now, why is it not format? I don't know.
Oh, it just randomly does that.
But I'm not sure how to do it. So I'm not sure it's easier when I thought it.
So before did we grab this obviously highbrow. Oh yeah, what? No.
No, not yet. Yeah, that's some weird logic. Not really ways. You can't. It's not a lot. Smiling, that's good, right?
But it's not working.
So these are backwards. Remember, name is input, right? So that's temporary. The underscore variables are permanent ones. So you're saying the permanent ones go in temporary. So really, it should be the temporary one.
Mine displays.
So
This one is
yeah,
over
that one.
Right after.
Otherwise, you weren't actually storing it.
So like right here, the minus comes. Yeah. It's logic.
Open it, if not, you only have to get on this side. Well, I don't know how you're just using it. So it's not really doing it loud. Well, rebuffer should be the whole buffer, right? So that one
It'd say if this equals that.
Yeah, see what happens with that. I don't use rebuffer that often, but I should read the whole strings. Just to the end.
That's absolutely.
I'm not sure,
But I mean, we have until October.
Yeah, otherwise, when you set that precision,
I like
actually.
Noticed.
yeah.
Hey.
So it's all good, right? You know the flex box?
Yeah.
I didn't submit that, I forgot.
What is that? I'm getting that. That's the initial policy that I don't talk about.
I need help on it. So I'll just come on in extra hour. I'll see you in like an hour.
All right, sounds good.
Yeah, I didn't know.
If we know it'll work, at least it seems like it'll work.
I'm just thinking of all the times that probably software engineers have done that in like a real setting. They're like,
Crap, I can't get this to work, let's just make it,
let's just put it forcibly into the.
yeah.
Interesting. That's a lot of binary.
Hey, we're looking good.
Yeah. Something's wrong here. What did I do?
Yeah, 9.6.
So it says we have to. Oh. Okay.
So you're seeing that screen, you're seeing that you're.
You have to massage it. Okay. It's not gonna lose.
That's gonna put